As we explore the mysteries of the deep ocean, the tools we build could help us search for life forms on ocean worlds across the solar system. Meet ABISS, an autonomous underwater observatory that researchers built to detect life in hard-to-reach places.
What first interested me in the deep sea was the idea that there was a whole part of our planet that was really poorly explored. And this vast majority of our biosphere, the inner space of our planet, is not easy for us to get to and to engage with. So we're forced to design tools that act as our eyes and ears. A few years ago, it occurred to me that there may be an opportunity to develop technologies that were relevant to both ocean and space scientists.
Whether on a distant moon like Jupiter's icy Europa, or off the coast of LA, chemicals in the water can hint at life. Deep in the dark ocean, life cannot make energy from sunlight. Instead, communities of bacteria use dissolved methane and sulfur that seep from the seafloor. Gerges and other deep ocean biologists can learn more about these communities through photographs and video, but also by studying the chemistry of the water over time. Previously, ocean scientists had to use unmovable objects like tethered moorings if they wanted to take long-term measurements or transmit lots of data, such as high-resolution video. Submarines and robotic vehicles can move around, but in general, they don't stay underwater for very long. Gerges's collaborators from the Woods Hole Oceanographic Institution developed a new kind of communication system, an optical modem, which solves that problem, permitting wireless communication underwater in real time. That means the ABISS can be moved around the ocean floor and still send lots of images, video, and other long-term measurements to the scientists on ship or on land without the use of a tether.
That means I can put my lander on the seafloor, and any number of scientists can go out with a ship and talk to this system wirelessly through flashing lights, if you can believe that.
This bright light flashes in a code sophisticated enough to transmit high-resolution video.
It's transmitting and listening. This is the transmitter. See, it's nice and bright. That's the listener.
That means scientists can see what the lander sees and operate its instruments in real time. Eventually, the ABISS will include an assortment of mass spectrometers for measuring dissolved gases and even a robotic arm, all controlled from the surface.
There they are. Okay. And everything's working great.
After Gerges and his team tested the optical modem system in air, it was time for the real test. They sailed out to a location just off the coast of Los Angeles on the EV Nautilus to drop the ABISS into the deep ocean for the very first time. Their mission? Trigger the modem to take a selfie of the ship's submarine from the ABISS, and do it without a physical connection to the ship.
Our hope is that this system becomes a model for how NASA goes about exploring the oceans in other worlds.
After a successful selfie mission, the team is now ready to fine-tune instruments on the ABISS so they can put it to work on the seafloor and eventually in space.
It's likely that we're going to find an ocean beneath a very thick ice sheet on the moon Europa. Now, what are those oceans like? Well, right now we have no idea. The possibility that microbial life lives beneath that ice sheet is very tantalizing. At the end of the day, the way to start exploring an ocean is to understand its chemistry and its physical condition. And the moment you have those data in hand, you can start to make educated guesses about the kinds of organisms you might find there.